So this video, this is video 3 of logarithms. This is where we're jumping back to the front page again, to the notes part, so we could really understand why things cancel out when we're simplifying logarithms or exponents. We need to really understand what an inverse is of a log, or an inverse of an exponential is. And we already know how to find inverse functions. Inverse functions, how do we do that? How do you find the inverse of something? Well, when it comes to an actual function, like if you have y equals 2x plus 1, how do you find the inverse of y equals 2x plus 1? You switch x and y, and you solve for y, right? That's how you do it. If you want to do the inverse of coordinates, all you do is switch x and y. But if you're talking about a function, you have to switch x and y and solve for y. So on the front part right here, we have, this is a growth function, exponential growth function. The base is 6. There is no h or k value. There is no a value. So it is a growth function. If they asked us to find the inverse, which they are, we're going to simply switch x and y, and you're going to have x equals 6 to the y power, right? And now you got to solve for y. So how do we solve for y if y is up here as an exponent? Okay, you guys got to understand this. The inverse of an exponent is a log, and the inverse of a log is an exponent. So if you have the y in the exponent position and you want to get it down to be a regular y instead of the exponent of y, you're going to technically have to apply a log base 6 right here. Because log base 6 of 6 cancels out and the y will come right down. But if you do that to the right side of the equation, you have to do that to the left side of the equation, log base 6 of x. So your answer is log base 6 of x equals y, or y equals log base 6 of x. Now, when we look at the big picture, well, that was already done for us. Sorry about that, I just wanted to explain it. But when we look at the big picture, we have an original exponential growth function, and the inverse of that exponential growth function is a logarithmic function. Okay, the inverse of an exponential growth is a logarithmic function. And not only that, the inverse of an exponential growth with base 6 is a logarithmic function with base 6. Right? If you were to plug them into each other, they would undo themselves and the x would be left over. So I hope we understand that a logarithm is the inverse of an exponent is the inverse of a logarithm, of course with the same base. Okay? Now, knowing that they are inverses of each other, they undo each other, right? Kind of like, let me go to the side over here. Kind of like if I had the square root of x and then I squared it. I'm doing inverse operations. That just gives me x. The square root and the square, the square root and the square, they cancel each other out and you're just left with x. That's what happens with logarithms and exponents. You could undo them if you apply them to each other. So here's a really cool trick. Let's say you had, we already know this for a fact. We know that log base 10 of 100 equals 2. Now what if I asked you why? Why is log base 10 of 100 equal to 2? You would say because what? Exactly, because 10 to the power of 2 is 100. That's why the answer is 2. This is the explanation for it, but the answer is 2. So we all understand that, right? Yay? Okay. So what I want to do now is, since we already know that this equation is true, what I want to do is mess with it, all right? It's kind of like if you had 3 equals 3 and then you add 1 to both sides, it would be a true statement, 4 equals 4. Or if you had 5 equals 5 and you take away 2 on both sides, it would be 3 equals 3. So we have a true statement. We already know that this is true. Now, we know that the inverse of a logarithm is an exponent. So check this out. I'm going to take this entire side and I'm going to make it the power of base 10. All right? And what I do to one side, I do to the other side. I'm going to also make this 2 the power of base 10. And instead of having my equal sign up here, I'm going to bring my equal sign down here. Now we know that the power and the logarithm undo each other. So if you have a log base 10 as an exponent of a base 10, that's going to undo itself. It's going to cancel out. The 100 is going to come down. So you're going to have 100 equals, and 10 squared, that is 100. So that's a true statement. Okay, so what I wanted to demonstrate right here is that you could get rid of logarithms by raising them. If it's an equation, you could raise both sides to be powers of the base of your choice. So if you have a log base 10, you could raise both sides to be powers of base 10 to cancel it out. Okay, now we're really not going to be working on equations on this section. On the next one we will. I just wanted to throw it out there already. And of course I explained this in the notes. It says down here, so whenever you want to get rid of a log in an equation, simply raise both sides of whatever base the log has, and ta-da, the log is gone, right? So here's a fact. 7 to the power of log base 7 of x, that's going to equal x, because 7 to the power of log base 7, those are inverses of each other. It cancels out, the x comes down. Or likewise, log base 7 of 7 to the x, that cancels out, the x comes down, so regular x. Okay? It says right here, let's look at log base 8. Whoa. Let's look at log base 8 of 64 again. Instead of thinking 8 to what power will give me 64, instead of thinking this, 8 to what power gives me 64, you could change the log base 8 of 64 to log base 8 of 8 squared. Okay? Now, why would we want to do that? Because we already know that log base 8 of 8 will cancel out, and your 2 comes down. And that's your answer. Right? It's just another way of looking at it, a different angle. Now, the original way of looking at how logarithms work, it's saying 8 to what power gives you 64. You know that the answer is 2. Here's a creative way of getting that answer. Changing the 64 to becoming 8 squared, and then the log base 8 of 8 cancels out. The answer is 2. So let's flip back over to that final part of our practice on the back side of these notes. And we might as well go through these again. Again, log base something of that same something, it cancels out. What's your answer? 1. Okay? This guy cancels out, but there's a power of x. So what happens with that power of x? It comes down and you have x. All right? Number 3. 3 to the log base 3 of x. Again, the power and the log, they undo each other. Now right here, because the log is a power, it cancels out with the base 3. So it cancels out, your answer is x. You got it? Number 4, this is a common log. Even though you don't see the base 10, it is base 10. Okay? Now, why am I emphasizing that? Because if for some reason this would be log base 3, all right, let's pretend that it was a base 3, then this base 10 with the log base 3 would not be able to cancel out. The only way they cancel out is if it's the same base. That's the only way it's truly an inverse, right? So because it's a common log, I need to emphasize that. Because it's a common log, that means that it's base 10. Base 10, not base 3. And now we know that 10 to the log base 10, that eliminates, and the 4 comes down. Your answer is 4. ln, that's a natural log of e to the 2x power. What is natural log? What is natural log really? It's log base e. So log base e of e to the 2x. So anytime you have log base something of that same something, it cancels out. What's left? Your final answer, 2x. Getting it? Yay or nay? Okay. How about number 6? E to the ln of 7. What would your answer be? 7. Because, I mean, you got to understand that ln is really log base e. All right, so yeah, e to the log base e cancels out. Your answer is 7. So that exponent comes down, becomes a nice natural number 7. It's no longer an exponent. Moving on, number 7 over here. This is another common log. Important to emphasize that the base on the log is really 10. Because that's the only way it's going to cancel out. The log base 10 of 10, that's the only way it cancels out. And your answer is 7x. Number 8. Interesting. Could I cancel out this log base 3 and 9? No, I can't. So, what do I do? If what would it be nice if this number were what? 3. If this number were 3, I'd be golden, right? Because I could cancel it out. Could I change the 9 to make it look like a 3? Yeah, how could I do that? 3 squared. Excellent. So the first thing to do is to rewrite the 9. We're going to rewrite log base 3, but instead of 9, I'm going to write 3 squared, which is the same exact thing as 9. It just looks different. And of course, I still have to the x power out here. And now, power to a power, you'd multiply. So you're going to multiply these powers. What is 2 times x? 2x. And what happens with the log base 3 of 3? Cancels out. So what's your answer? 2x. It's not 2 to the x. All right? It's not 2 to the x. You got to remember, the power to a power, you multiply. I mean, if you really wanted to show your work here, you might want to rewrite the whole thing and say log, go in this way, log base 3 of 3 to the 2x power. Because the power to a power you multiply, you write it over here as 2x, right? And then you do the canceling. Log base 3 of 3 cancels, your answer is 2x. Okay? I've seen people write it as 2 to the x. That's incorrect, because a power to a power, right here, you multiply. So 2 times x is 2x. So we are going to have to get creative. Right here, what would be nice if this number were 4? If it were a 4, that'd be great. I'd be able to cancel out log base 4 of 4. Could I rewrite 16 as 4? Heck yeah. So let's go log base 4 of a new number, but to the 5x power on the outside. What's that new number going to be? 4 squared. Okay? And now power to a power, what do you do with the power to a power? Multiply. So I really have, I'm showing my work here. I know, what? That's not log. LG. Log base 4 of 4 to the 10x. That's showing my work. I know later on you guys will just skip this step and get straight to your answer. This cancels out. Your answer is 10x. So ladies and gentlemen, even if you guys already have calculators that could do logarithms with different bases, or even if you figured out how to do logarithms with the change of base formula on a calculator, it's not good enough. You still have to learn how to manipulate and see how they actually work, because when you have a variable, you're not going to be able to do that on a calculator. So the answer here is 10x. All right, how about number 10? Could you guys do number 10? So log base 5, instead of 25, we're going to write 5 squared. And of course, it's to the x power. Multiply power to a power. So you're going to end up with log base 5 of 5 to the 2x power. And of course, the log base 5 of 5, that cancels out. So your final answer is just 2x. You see, it's easy. 11, that's a hard one. I'm just kidding, it's not. What's the answer? 6. Cancels out. 6. Done. Well, that one could be a little more interesting. Anybody have an answer to that one? 16x. 16x sounds good. Yeah. Why is that? Because you could convert. Oh, first of all, you got to think, it would be nice if this were a 3. That way you could cancel out with log base 3. So you think, it'd be nice if it were a 3. So could you change it to a 3 to a certain power? And yes, you could change to a 3 to the 4th power. Rewriting the rest, log base 3 of 3 to the 4th, and it still has the 4x power outside. So power to a power, you multiply. This will be a 16x. So let me rewrite everything just to show my work. Log base 3 of 3 to the 16x. And the log base 3 of 3 cancels out. 16x is your final answer. Jumping to number 14, what would be nice what number would I like to have in the parentheses here? 2. That's right. So we're going to rewrite that as 2 to the negative 3 power. After all, that does equal 1/8 with the negative exponent. So you multiply the exponents and you'll get negative 3x. And of course, log base 2 of 2 cancels out, which means that your answer is negative 3x. Final answer there.